600 meters beneath the surface of the Caribbean Sea, the water is pitch black, the temperature hovers near freezing, and the pressure is enough to crush a human being instantly. For over 300 years, this hostile environment off the coast of Colombia has guarded the holy grail of shipwrecks, the San José. But as of late 2025, the silence of that grave was broken, not by divers in wetsuits, but by avatars of steel and silicon. This is the story of the San José extraction and how deep-sea robotics are rewriting the rules of maritime archaeology. To understand why the world is watching this operation so closely, we have to go back to the catastrophe that started it all. On June 8, 1708, the San José was the flagship of the Spanish treasure fleet. It was sailing from Portobello, Panama, to Cartagena, its wooden hull groaning under the weight of an empire's taxation. We are talking about chests overflowing with Peruvian emeralds, millions of gold and silver coins struck in the Andes, and the personal fortunes of Spanish viceroys. It was a floating bank vault. But it never reached Cartagena. Near the Baru Peninsula, the fleet was ambushed by a British squadron led by Commodore Charles Wager. The British wanted to capture the ship intact to seize the prize, but in the heat of the cannonade, disaster struck. The powder magazine of the San José detonated. The explosion was apocalyptic. Witnesses described the massive vessel shattering and vanishing almost instantly, taking 600 souls, the captain, the general of the fleet, and nearly the entire crew, straight to the seafloor. For 307 years, the wreck remained a ghost story. Its location was a mixture of myth and conjecture. Treasure hunters spent generations looking for it, haunted by the estimated $20 billion in value sitting in the mud. But the ocean does not give up its dead easily. The breakthrough finally came in 2015, and it wasn't due to a ragged map or a stroke of luck. It was a masterpiece of engineering led by the Woods Hole Oceanographic Institution and the Colombian Navy. This is where the technology begins to take center stage. The hero of the discovery phase was the Remus 6000, an autonomous underwater vehicle, or AUV. Unlike the old-school method of dragging a sonar sled behind a ship on a long cable, the Remus 6000 is a torpedo-shaped robot that operates independently. It swims through the deep, mowing the lawn, which is the industry term for scanning vast swaths of the ocean floor autonomously with side-scan sonar. When it found the San José, it didn't identify it by the glint of gold. Sonar doesn't see gold. It saw the geometric unnaturalness of bronze cannons scattered on the seabed. To confirm the find, the Remus dropped down to just meters above the bottom and snapped high-resolution photos. Those photos revealed dolphin engravings on the cannons, a specific marking that provided the positive identification needed to confirm that this was indeed the San José. But finding the ship was just the prologue. The real revolution, the one that unfolded throughout 2024 and peaked in late 2025, was the extraction. This brings us to the engineering challenge of the century. How do you recover fragile artifacts from a depth of 600 to 900 meters? At that depth, the pressure is roughly 60 to 90 atmospheres. The currents are unpredictable. No human diver can work there. The archaeologist has to become a pilot, operating through the eyes and hands of a remotely operated vehicle, or ROV. The operation, codenamed towards the heart of the San José Galleon, utilized a specialized heavy work class ROV. Picture a machine the size of a minivan, tethered to a mothership on the surface by a thick umbilical cord that transmits power and massive amounts of data. This robot is the hands and eyes of the mission. It is equipped with a sensory suite that makes it hyper-aware of its surroundings. It carries 4K and 8K cameras, providing clarity that is actually superior to the human eye. This allows archaeologists sitting in an air-conditioned control room kilometers above to inspect the hallmark on a coin or the glaze of a teacup in real time. It also uses laser scalers, projecting parallel laser beams onto objects to measure their size precisely without ever touching them, and sub-bottom profilers, which are acoustic tools that can see through the sediment, revealing artifacts buried meters deep in the mud without digging. But the most critical challenge in the 2025 extraction phase was the physical interaction. This is where the engineering gets incredibly clever. Standard deep-sea robots are built for oil rigs. They have hydraulic claws designed to turn heavy valves or cut thick cables. If you used a standard hydraulic claw on a Ming Dynasty porcelain cup, you would crush it into dust instantly. To solve this, the mission employed soft robotics and force feedback, or haptic, technology. Instead of rigid metal claws, they developed soft grippers. These end effectors mimic the human hand, often using silicone fingers inflated with fluid. They gently wrap around an object, conforming to its shape. If they are picking up a 300-year-old ceramic jug, the soft gripper distributes the pressure evenly across the surface to prevent cracking. It's the difference between grabbing an egg with a pair of pliers versus holding it in your palm. For objects that were partially buried, they didn't use shovels. They used suction limpets. These are low-flow suction devices that act like gentle vacuum cleaners. They remove centuries of silt without the abrasive violence of a standard commercial dredge, revealing the object underneath. Once an object is gripped, you can't just yank it up to the surface. The change in pressure would be violent. The mission used variable buoyancy lift systems. Think of it as an elevator for artifacts. The object is placed in a basket with its own buoyancy control, which gently ascends to the surface at a controlled rate to manage the pressure change. In November 2025, this technology proved its worth. The world watched as the first artifacts were recovered: a bronze cannon, a pristine porcelain cup, and silver coinage. These weren't encrusted lumps. They were recognizable treasures, handled with the delicacy of a surgeon by a robot pilot. However, bringing an artifact up from the deep is actually a traumatic event for the object. This brings us to the science of survival. Conservation. For 3 centuries, materials like wood and iron have reached an equilibrium with the salt water. The iron is saturated with chlorides, or salts, and the cellular structure of the wood is often held up only by the water inside it. If a wooden timber from the San José were simply brought to the surface and allowed to dry, the water would evaporate and the cells would collapse. The wood would literally turn to dust. If an iron cannon were exposed to oxygen without treatment, it would rapidly corrode and disintegrate. To combat this, the Colombian Navy established a world-class conservation facility in Cartagena. The protocols are rigorous. Artifacts are immediately placed in tanks of chemical solutions to desalination, gradually leaching out the salts. This process can take years for large cannons. For the metal, they use electrolysis. They hook the artifacts up to an electrical current in a bath of electrolytes. This reverses the oxidation process, converting the rusty crust back into stable metal or allowing it to be safely removed. For organic materials like wood, they use PEG impregnation. PEG, or polyethylene glycol, is a wax-like substance. They slowly replace the water inside the wood with PEG, which bulks up the cell walls. This ensures the wood keeps its shape even when it eventually dries out. While the robots work silently in the deep, the surface is noisy with legal and diplomatic thunder. The San José is not just a shipwreck, it is a geopolitical flashpoint. There is a massive war for ownership happening right now. First, you have Colombia's stance. For Colombia, the wreck is submerged cultural heritage. The government has pivoted the narrative from treasure to heritage. They argue that the ship lies in their territorial waters and that they have the sovereign right to manage it, declaring the site a protected archaeological area. Then, you have Spain. Spain argues that the San José was a state vessel, a warship of the Spanish Armada. Under international maritime law, warships remain the property of their flag state, regardless of where or when they sink. Spain views the site as a war grave for its 600 sailors and has historically opposed commercial salvage. Then there is the Sea Search Armada, a group of American investors. They claim to have located the wreck initially in the early 1980s, acclaimed Columbia disputes, stating their coordinates were wrong. They have been in a decades-long legal battle, demanding 50% of the treasure's commercial value. And finally, perhaps the most morally compelling claim comes from the Caracara nation of Bolivia. They argue that the gold and silver in the galleon's hold were mined from the bowels of the Andes, specifically the Potosi mines, by their enslaved ancestors. To them, the treasure is blood money that should be returned to the people from whom it was stolen. Despite the legal maelstrom, the robotic arms of the San José expedition continue their work, and a shift in perspective is occurring. The initial headlines screamed about billions of dollars in gold, but the artifacts recovered in late 2025 tell a more human story. The porcelain teacups speak of the global trade networks connecting China, the Americas, and Europe. The personal armaments reveal the fear of the crew sailing in pirate-infested waters. The coins are not just currency, they are historical documents stamped with the date and place of their creation, offering a snapshot of the colonial economy. The extraction of the San José is a testing ground for the future of archaeology. It proves that we can access the deepest museums on Earth without destroying them. We are no longer smashing and grabbing. We are visiting and learning. The Holy Grail has been found, but the real treasure isn't what we can melt down and sell. It is the technology that allows us to reach back through the crushing depths of time and ocean to hold history in our hands, intact and unspoken, for the first time in 300 years.